Hello. Today we're talking about how to formulate your research object, subject, goals, and tasks for any research projects. So whether it's your master's thesis, some term paper, or research article you want to publish in a journal, the principles are generally the same. So what's the difference between an object and a subject? Object is something general. So it's this broad process or phenomenon that causes the issue and is chosen for the research. So it's a broad description of a problem you want to solve. So, for example, if Dennis wants to study high entropy alloys, it's probably because some castings made of traditional steels or cast irons don't have sufficient enough properties. So, therefore, the object could be those insufficient mechanical properties of manganese steels or cast iron or any other alloy. So, for example, if you are researching something about equipment, right, for your foundry, you could your object could be the life cycle of an induction furnace or predictive maintenance of your die casting machine, for example. So it's something general, a broad topic you are going to study somewhere where there is a problem you're going to solve. So object is general and subject is partial or specific. So you take your broad object and narrow it down to a specific process or phenomenon within the object scope that is considered part of the research object. So, for example, if your object is the insufficient mechanical properties of manganese steels, when you narrow it down, you can create a subject about the influence of phosphorus and sulfur percentage on the tensile strength of manganese steels. So it's like using Google in the olden times when you had some keyword and when you were searching using a generic keyword, you got lots of results. But when you added extra terms to your keyword search, right, you would get the results that are more specific. So the principle here is the same. So first you formulate generally which area you want to study, and then you narrow it down to a specific issue. Let's look at a couple of examples. These are examples taken from real life dissertations by some of our past doctoral students. So these are direct translations from their dissertations. Here's the first example. So object is the structure formation processes in nickel, chromium, aluminum ingots. So we have a specific alloy, ingots made from this alloy, and the structure formation processes in those ingots. It's still pretty broad, but not hugely broad. Narrowing it down, we get the subject. Regularities of ingot structure formation and its influence on the properties of heat resistance coatings obtained by vacuum physical vapor deposition. So now we are not just studying the structure formation in ingots for its own sake. Instead, we are researching those properties and how they affect heat-resistant coatings made from those alloys. So broad and specific. Second example is goes like this. object is processes that ensure the formation of protective diffusion layers on cast iron and steel components for chemical equipment. So once again, it's pretty broad because those protective layers on cast iron and steel components for chemical equipment, and once again, it's generic. The subject is regularities in the transformation of the structure and operational properties of protective layers formed as a function of the saturation mixture composition and various complex activators. So here we specify what exactly we are going to study within the object of our research. So once again, adding details and making it more specific than the object. So, any questions?
Наче все зрозуміло.
Great. I just wanted to mention because it's very tempting to make your object too broad. For example, you can write, the object of my research is foundry technology. Well, that's too broad for an object. Once again, you should first formulate the problem you are solving or your research question, or however you want to phrase it. So, for example, if it's for example, you're designing a foundry, right? And you think that the castings you make of like some cast iron don't function as long as you want them to function. So your buyers have to replace them too frequently, and so they are thinking of switching to another manufacturer, for example. So here your problem is the longevity of cast iron castings or parts. And that would be your object. So somewhere where there is a problem. And next, your subject would be more focused on the specifics of that problem or one of the way you could solve it. For example, you could replace your cast iron with steel, so change the alloy. That would be one subject. If you could maybe add some alloying elements or modifiers to your alloy to make it stronger, that would be another subject within the same object. You could maybe change the design of the part to make it more, make it stronger. That will be the third subject. So within one object, there can be many subjects. And your goal is to find the one that you are interested in and to build your research project around it. Well, hopefully you understand what I mean. So please don't make your objects just too broad and too generic, like stainless steel. That's not an object. Stainless steels are great. So what exactly do you want to make better about them? That would be your object. Okay, moving on. Next, you will need to formulate your research goal or purpose. And you should always phrase it as a final outcome. So your purpose should be what you want to achieve. And that purpose or that goal should be reflected in your thesis title and include, well, those outcomes you actually want to achieve. So once again, let's look at some examples. For instance, we are going back to our cast iron foundry, and your final purpose is to extend the life cycle of your parts. So that would be your goal. So extending the life cycle of cast iron parts And you can add something about how you are going to do that. So which methods you are going to use, either in your title or in your research goal or research purpose. So focus on the outcome. It's not, we don't do research just for researching because we like it so much. We always work towards some result, some outcome, some insight. And that should be your goal or your purpose and how you formulate it. When it comes to research tasks, they work under the goal, so they are directed toward achieving your goal. So they should be goal compliant. They can refine the goal, and they should be designed to achieve your goal step by step. So when you complete your research tasks, you achieve your goal. Once again, you can, in most cases, you cannot achieve your goal in one step. So usually there are at least 3 or 4 or 5 steps you have to take to get there. For example, first you need to research some studies and see what other researchers have done about it. Maybe they've already solved the problem and you don't need to study anything. Next, you will need to, for example, create samples. That would be your second task. The third task would be to, for example, optimize your technological process. The fourth would be to test your new suggestions in a lab setting, and the next one would be to test your new technology in a real life setting. So all these tasks would lead to achieving your goal, which you wouldn't be able to do in one step. So that's why we split our purpose into several tasks. And like your research goal or research purpose, you should focus on results, not processes. So don't just say that I will be studying the relationship between the chemical composition and the mechanical properties of an alloy. So studying is a never-ending process, right? So you might be studying for your whole life and never learn anything. Hopefully not, but it's possible. Or research into the composition of high entropy alloys. Once again, it doesn't show what you actually want to achieve by completing this task. Instead, you should focus on the goals, the results. So, identify a relationship between, for example, alloy composition and mechanical properties. So, the end result of achieving this task would be some diagram or graph or table that shows this relationship, or develop a technology, or get, for example, test results. Those are results, not processes. That's important. I know it might seem like I'm just nitpicking and trying to focus on things that don't actually matter, but trust me, it helps to structure your thinking and structure your later research. And once again, it helps you understand what you want to actually achieve, especially if it's your first big research project. So, any questions? No?
No, Maya.
Okay. So, let's see what types of research tasks they are and which one you might need. So they are here in order of how you would usually complete a research project. The first steps are usually theoretical. So you're studying some sources, finding out what's already there, and defining your problem, defining the terms, developing criteria or indications for success, studying theoretical principles. So usually the first task of any research project is understanding the theoretical context or theoretical background of the problem. And you can actually include it in most projects. The second task would be clarification. So you are analyzing knowledge gaps and discrepancies, searching for trends, clarifying the subject's nature or structure. So, for example, Dennis has chosen the topic of high entropy alloys, right? And we've seen today that there are different methods of actually manufacturing them. So there's mechanical alloying, directional solidification, and other methods. So by comparing them, you would be analyzing discrepancies, analyzing knowledge gaps, and searching for trends and identifying where you could offer something new to this topic. So that would be the second task, understanding where there is room for improvement. The third step is usually that same improvement we've just talked about. So you might suggest some ways to improve the process, or finding ways to resolve the issues. So, for example, if we are talking about foundry technology, for instance, you notice that your you run simulations and you notice that your castings usually have shrinkage defects in their largest parts. And so that's your problem. And you can suggest improvements, for example, by adjusting your gating system or by adding some other components to that system to remove those shrinkage defects. So that would be your improvement. And testing would usually imply some sort of experiment that checks your improvement and helps you check whether they work or not. So, do they solve the problem or not? Do they make it better? Do they make it worse? And all the rest. Testing can be theoretical, for instance, using computer modeling or simulations. It can be lab-based. So, for example, you are checking using physical modeling or using some samples in a lab setting. Or they can be practical. So, in a real life scenario, for example, if it's a foundry, you can suggest those changes to the gating system. And if they are implemented and you get the results back, so that's how you know if your suggestions work or not. Those are typical types of research tasks. And a few other ways you can structure your tasks depending on your topic. So they can be physical tasks, so identifying relationship, physical meaning related to physics, not physical as in you have to manually do something. So identifying relationships between mechanical, electrical, chemical, thermal phenomena that affect the research object and subject. So, for example, in the case of those high entropy alloys we discussed today, that would be the addition of aluminium and how it affects, so how the chemical composition of a high entropy alloy affects its mechanical properties. That would be a physical task, meaning related to physics. There can be identification or description tasks. Those are usually where you provide mathematical description of the causation between the input and the output. I know the definition is a bit complex, but generally it's when you run an experiment and build a diagram or a graph showing the relationship between x and y. For example, the relationship between pouring speed and casting quality, or the relationship between pouring temperature and the viscosity of the alloy. So those would be identification or description tasks where you find that relationship and represent it either in numbers or visually on a graph. Optimization tasks usually require specific optimization calculations, and those calculations help search for the optimal combination of inputs for achieving desired outcomes. So that's, for example, if you have too many factors to test them all, that's when you can run optimization calculation. For instance, if we are talking about those high entropy alloys, they usually have like 5 or 6 different components. And if you try testing changing their composition by one chemical element, you would have too many compositions to try, and it would cost too much, it would take too much time. And that's why you can run optimization calculations to identify that optimal chemical composition of a high entropy alloy based on some preliminary data. So once again, optimization is for when there are too many factors to account for. That's where optimization tasks are or work best. So the next are search tasks. Those are ways to look for the most effective way of achieving the research object's demands. So, for example, you have a problem and there are lots of ways to solve it. So once again, if we are talking about, for example, steel strength, well, can you suggest any methods for improving the strength of steel? Let's count how many you can suggest. So how do we improve steel properties, mechanical properties of steel? Any suggestions? No? Okay, let me give you a couple of examples. For example, I can adjust the chemical composition of steel and add some additional alloying elements to make it stronger. That's one way. I could add modifying elements, right, to affect its microstructure and improve mechanical properties. I could use heat treatment to make it stronger and more improve its plasticity. I could maybe reduce the number of impurities and inclusions, for example, by using some refining techniques. I could, well, once again, it depends on what type of part we're talking about. I could use some additional coatings or other ways to treat steel parts after they are already finished to improve their quality, their properties. So, and searching for the most effective way or combination of way to resolve this problem would be a search task. And finally, manufacturing tasks are for testing new technologies, new equipment, any improvements that you have created in a lab, but you want to transfer to real life conditions and to check if those improvements or methods or new suggestions actually work in a real life environment. So these are potential tasks you can include in your research projects, once again, depending on your research purpose, your subject, and your object. Do you have any questions or comments?
No.
No? Okay, then let's move on and look at an example. So, once again, it's a translation of an actual PhD dissertation of a couple of years back. So you can see how the objective and tasks are actually formulated in real dissertations. So the objective was to improve the metallurgical processes for producing cathodes of new geometries and compositions by enhancing the comprehensive set of qualitative and technological characteristics of the ingots. So here we have two parts of the objective. The first part, so improving metallurgical processes for producing cathodes of new geometries and compositions. That's the purpose of the work. And the second part, after by, is the way we are going to achieve that goal. So by enhancing the comprehensive set of qualitative and technological characteristics of the ingots. So the problem we are solving and one of the ways we are going to solve it. That's the objective or the purpose. Next, to achieve this objective, the author of this dissertation suggests the following tasks. So, the first one is to investigate the influence of technological factors in cathode manufacturing on the deposition process and the formation of heat-resistant coatings. So, see, this task falls under our theory or clarification category. So, it involves research into what's already known. So, that's your literature review, basically. The next task is to investigate the influence of technological factors on the deposition process and the formation of heat-resistant coatings on gas turbine engine components. So here, this task could be either theoretical or clarification, or it could already be practical. So when the author would see and test in lab conditions how different technological factors affect that deposition process. So this one could either be practical or, once again, theoretical, depending on the conditions of the research. The next one is to investigate the effect of modifying elements on heat-resistant characteristics. So here we see the practical part of the research where the author would use different modifying elements and see how they affect that heat resistance characteristic. So that would be the description process, and the goal of this task would be to create some sort of graph or identify a relationship or a formula for different modifying elements, for example, depending on their quantity introduced to the alloy. Next task is to examine the structure and properties of coatings obtained on serial and new equipment using cathodes made of modified nickel alloys. So we see one task comes out directly from the previous one. So first, the author would investigate the effect of modifying elements, and next, he or she would use that knowledge to examine the structure and properties of coatings obtained using those cathodes made of modified nickel alloys. So all tasks are connected, and you have to go through them one by one to achieve your objective. The next one is to develop a technology for removing gradient heat resistant coatings from blade surfaces without damaging their geometry. So this one may seem a little strange because doesn't it doesn't seem related to other tasks, right? To the previous ones. But if you think about it, so first we study different factors affecting the coatings, then we create those coatings using the knowledge we've obtained, and next we see if we can remove those coatings without damaging the parts. So maybe to reapply them. So if you look at it this way, it kind of seems logical. And finally, the final tasks, it falls into manufacturing category, is to manufacture prototypes of gas turbine engine components with the modified coatings applied. So if at the fourth step we would examine, or the author would examine the coatings maybe on some samples or on some parts that would not actually work as a part of a gas turbine engine, then at the last step it would be actually testing that new knowledge in real life conditions. So manufacturing actual components with the modified coatings and probably testing them in real life conditions, maybe not on live engines, but on some test stands. So these are the objective and the task examples. Of course, if you are dealing in your research projects, you are dealing only with the literature review part, then your goal could be, for example, to develop or to suggest, for example, a new technology for improving the quality of your cast components. And that would be your objective. And to achieve that objective, all of your tasks would mostly be theoretical or clarifying or maybe descriptive. So you could look for some information about the influence of coatings or heat treatment or different alloying elements on something and synthesize some new information based on that information you would suggest improvements to your technological process that already exists in your foundry. So that would be your objective and those would be your tasks. Well, hopefully I'm explaining it clearly, but if you have any questions or comments, please voice them.
Зрозуміло.
Great. Then let's quickly sum up what we've learned today. So I added an icon of a pizza to explain the difference between the object and the subject. So object is something general and subject is partial or specific, like a pizza pie and one slice of a pizza. So please remember that your research subject should be present in the thesis title and research goal, and it should be specific to a problem you want to resolve or solve. When you formulate your research goal, focus on the final outcome, not the process how you're going to achieve that outcome. And finally, use research tasks to clarify your goal and split it up into smaller chunks you can complete step by step to achieve that research objective or fulfill your research purpose. And that's all for today.